Hello, good day. This is Alpha here again. Welcome back to my channel. And today we're going to be looking at how the internet work. So we'll be answering the question, how does the internet work? And this is video 2 in the Cybersecurity from Scratch series. In this video, we're going to be looking at what the internet actually is. Spoiler alert, it is not a cloud. So if you actually thought the internet was like a cloud up in the sky, you'll be wrong. So the internet is not a cloud, but we'll be looking at what the internet actually is today. Then we'll be moving on to DNS, how DNS translates names into IP address, what DNS even means, what IP addresses are, and how they are derived. Then we would also move on to why your data gets chopped into packets. I bet you didn't know your data actually gets chopped into packets. We'll be looking at that as well. Then the journey packet takes through the internet, through routers. How does your packet, how does it move through the internet? We're going to be looking at that as well. Then how everything reassembles at its destination. When your packet, chopped up packet gets to its destination, how do they reassemble themselves? How are they able to reassemble themselves when they get to the destination? And then we would also be looking at where hackers attack at every step of this journey. That is very, very important for us as cybersecurity professionals. So we'll be looking at how hackers attack each step and where exactly in each of these steps can they actually attack. So the big question is, what happens when you type google.com and you press enter on your keyboard and all of a sudden in millisecond you're presented with google.com's homepage, right? But what are the processes that actually happened that made that possible for you? A lot of things went on in the back end that we don't know about. So those things that went on in the back end are the things that we're going to be dealing with today. But before we get started with that, first let's bust this myth. Right now, we're going to be displaying these two images. I'm sure you're seeing these two images on your screen right now. One is of a cloud and one is of some things here. So I want you to go into the comment section and tell me which one you think is actually the true internet. Well, I'm sure I already told you in the beginning that internet is not actually the cloud. So you'll be smart enough not to say the cloud. All right, the internet is not a fluffy cloud in the sky. It is physical. The internet is as physical as you and I right now. It's millions of miles of fiber optic cables running under oceans and across land. It's massive, massive data centers filled with servers. Your data travels through real, tangible infrastructure. So as far as your data is not visible to you, it actually travels through physical infrastructures, data centers filled with servers, and servers are actually computers as well. So as much as we know it, your devices are actually parts of the internet. Whether you like it or not, it helps to contribute to the internet, as well as the servers in the data centers and the optic fiber cables run across the oceans and across lands as well. So that is the true internet. And this image down here is actually showing how fiber optic cables are actually run across the world, connecting us all together. So all of these green, red, blue lines are actually optic fiber cables connecting each world. So the journey begins. Where does the journey actually begin? It begins with your computer. Your computer speaks. But for your computer to speak, what does it need? It needs internet access, right? So your device, be it a laptop, phone, or tablet, is assigned a unique digital address known as an IP address. And how does it get this address? So your device wants to connect to the internet. It connects to a Wi-Fi being provided by your home router, right? So your home router is actually what gives your device this IP address, this internet access. So once it's being given an internet access, it needs to be given an IP address as well. So this IP address is what is being used to connect to the network or to the internet. It was also used to identify and communicate with that device. So if that device wants to communicate with another device on the internet, it needs an IP address. The IP address is basically your home address. you have your home address, you want to send a letter, your letter needs to have your home address on it, so that the person you're sending it to would be able to send a return letter to you to your home address. And also, of course, you need to have the destination address as well on that letter for the letter to be able to get to where you want it to get to. How does the router actually get this done? So there is a protocol called DHCP, which is Dynamic Host Configuration Protocol. So this is the protocol that is being used to automatically assign an IP address to each device that is connected to a network. We were talking about IP address, but do we even know our IP address, the IP address on our devices currently? So let me show you how you can actually get the IP address on your Windows PC right now. So let's go to the command prompt. To get your command prompt, all you need to do is press the Windows key on your PC and you search command prompt, press enter, and this command prompt box is going to be displayed to you. So how do we get our IP address? So on your Windows PC, all you need to do is type ipconfig and press enter, and you'll be displayed with all of this. So what you need to look for is, if you're connected through a Wi-Fi, you need to look for the wireless LAN adapter Wi-Fi, and this is going to give you your IP address. So this is your IP address here. My current IP address is 192.168.0.139, and also, so there is something we call the default gateway. So this default gateway is actually your post office address. So the post office is like your router, basically. So your router also needs an IP address. So you communicate with the router, and the router communicates with the internet on your behalf. So you send your letter to the post office, and your post office actually sends the letter on your behalf, right? That is what the router does in this case. So the IP address for my current router and default gateway is 192.168.0.1. And if your PC or your computer is actually connected through LAN cable to an Ethernet cable, all you need to look for is this Ethernet adapter Ethernet. Mine is not currently connected, so I don't have any information here for you or for me. So that is how you find your internet IP address. So the next is finding the destination. How does your packet find its destination? So there's something we call DNS. So the DNS is actually the internet phone book, and we know also that computers don't understand the human language that you and I speak. They speak in ones and zeros, right? So does the internet. The internet does not understand the addresses that you input into it, like google.com, youtube.com, and so on. It actually understands IP addresses. So DNS has a table that assigns an IP address to an address that's a website address that you and I understand, you and I can type out. That is what a DNS does. So when your computer wants to reach out to google.com, remember I said that when your device wants to reach out to the internet, it sends the information to your router, and your router reaches out to the internet on behalf of your device. So when your router reaches out to the internet, it goes first to a DNS server, and it requests that, oh, I need to get to google.com. I need the address that is assigned to google.com. And the DNS server responds to that request and says, oh, google.com resides as, for example, let's say 8.8.8.8. And then your router actually use that information to now reach out to google.com's main address, which is at 8.8.8. That is how you are being presented with google.com. So DNS actually means domain name system, and it translates google.com into an IP address like 192.172.217 and so on. Let us show you how that process actually works in the backend. Let us see on the backend how we can actually get the address that google.com actually resides in. Back to our terminal here, we're going to send a request to a DNS server to tell us where google.com actually resides. And I want you to do this as well and type in the comments what IP address you actually get, your DNS server actually sends to you that google.com resides at. For you to get that, you need to type in nslookup space google.com and you press enter. And here it is. Currently, google.com for me resides at 216.58.168.0.1. 192.223.238. That is where google.com resides for me. One more thing I would like us to do is, we said that when we input google.com on our browser, it takes us to google.com, right? But what happens when we actually input this IP address? So I'm going to copy this right now. So let's go to google.com, youtube.com, and then so from here, let's input the IP address and then click enter and see where it actually takes us. See, it takes us to google.com. So that actually shows that google.com actually resides at that IP address that I was shown by the DNS server. So the next step is your data actually gets chopped. So once all of this process has been done, your data gets chopped into packets. So the request doesn't get sent at once because there is a limit to the size of packets that we can send at once on the internet. So your data needs to be broken. It needs to be broken into smaller parts called packets. So we call these small parts packets. And then each packet has a header. Let's assume we want to send a 4-layer cake for a wedding. We just baked your baker's. So we just baked the 4-layer cake for a wedding, and it's so big that it can't go in a single delivery vehicle. So we need to send each layer on a separate vehicle. So that is basically how the packets work. So each of those vehicles, we need to have the source IP address, which is our own address, home address, and also the destination IP address, and also a packet number. So it's in layers, right? So the first layer, which is the base layer, needs to have the lowest number as like layer 1, so that when it gets to the destination, whoever is going to assemble it would know which layer is the base layer, is the layer 1, is the layer 2. So that is why we need the packet number, so that when it gets to the destination, whoever is going to be assembling it would know which layer goes first and which layer goes second. That is why the packet numbers are very, very important. And this transportation is actually being done by two protocols. One of the protocol is called TCP, which is Transmission Control Protocol. So, and also the second one is UDP, User Datagram Protocol. Your browser, your internet, your router decides which protocol to use for either of the type of communications that we want to do. And if you want to try to learn a little bit more about protocol, you could read about that, or you could watch a very short funny video that I made about it. I'm going to drop the link in the comment section or in the description. So the next is the routing journey, packets on the move. Your packets actually travel through routers. We said it earlier that the internet is actually physical devices across the internet connected to each other, data centers, routers, fiber optic cables. So how does your packet really move? Your packets don't take direct paths. Remember, we have multiple packets from a single data that has been sent. So all of these packets don't take the same routes to the destination. They take multiple routes. So each router that each packet gets to, that router reads the IP address and decides the next best hop, and that hop is the next router that is going to get to. So maybe, for example, one router receives a packet right now, and then it's connected to like 3 other routers. So it decides that, okay, for it to get to this destination IP address, this router on my right is actually the best next hop for this packet to get to its destination. And it may receive, and that same router will receive another packet and decides, oh no, this one on the left, that it's going to be the best for it to actually get to its destination. So that is how that works. So packets from the same request might take different routes, but the most important thing is all packets eventually arrive at the destination and are reassembled. Now, the server response. So when the server gets your data, like Google server, it receives your request, and then it finds the web page that you want, that you've requested for. Then it breaks that web page into packets, the same way your device has broken your data into packets and sent through the internet to you. The same process is being done from the server's side, and then those packets travel back through routers to your device, and then your device reassembles them and displays the page that you need. So that is how the internet works basically. Let us do a quick summary. This is what the diagram of what the internet would look like is. This is our laptop, our device that wants to send, that wants to request access to the internet. And then it communicates to the router, the home router that has provided an IP address for it. So let's say this router is 1.1.1.0, and then your laptop's IP address is 1.1.1.1. So that is the IP address for this particular network. And then for the DNS server, it could be 2.2.2.2. And then let's assume our Google server actually resides at 8.8.8.8.8. So now we want to access google.com that resides at 8.8.8, but we don't know that google.com resides at 8.8.8. So our laptop will say, oh, I want to access google.com. It tells the router on behalf of the laptop goes through the internet. So all of this and this actually resides here in the internet. We just brought it out for us to be able to see. So goes through the internet and says, oh, I need to know where google.com resides. I need to know the address of the google.com. So I need to go to the DNS server and request. So he sends a request to the DNS server, and then he says, oh, I need the address of google.com. And then the DNS server responds and says, oh, google.com resides at 8.8.8. And then the router says, oh, great, thank you, DNS server. And then it sends the request, because now we have google.com's address. So it can now communicate directly to google.com on the internet as 8.8.8. And then once the data, all of the packets has gotten to google.com, it reassembles the data and then sends back the request that has been asked from the router, and then the router sends the response back to the device. So basically that is how it works. But also let's go deep into the internet here. So basically this is how the internet works, and then we can actually do the analogy of the hops here. We can do the analogy of the hops. So let's say a packet comes in through here, gets to this router, and then the router will decide, oh, so this router is connected to this router and this router, and that packet needs to get to this destination, and here is the router here. So it needs to decide which of these two routers is the best way, the best router, next best hop to send this packet to. So it decides, oh, this is definitely the next best hop to send the packet to. So it sends to this. So all this process also prevents us from having downtime, because let's assume this router is not functioning, and this is the best direction, or this is the only direction, or this is the best direction. Basically, we've decided that, oh, we've concluded that this is the best direction, right? Next best stop that is supposed to get to this destination, and then it's not working. There's another direction. There is a different pathway that it can take to it. It may be longer, but it is also going to, the main purpose of this is for the packet to actually get to its destination. So it sends to this device, to this router, and then this router decides, oh, which of these two routers, 1 and 2, is the next best hop for this packet to get to its destination. Obviously it is this one, but some circumstances may arise that the router will decide that, no, this is the next best hop for this packet to actually get to its destination. and then it sends to this, and then eventually this sends to the final destination, and the packet gets to its destination eventually. So that is basically how all of these hops and all works. So going back to this, how and why does this really matter in cybersecurity? It matters because we need to know how all of this works, because all of these steps, all of these points, all of these devices, all of this junction, everything is actually an attack surface to a threat actor. So your device can be infected by a malware. Your router too can also have default passwords. And when you set it up, you don't change the default password. That default password is actually in the documentation of that router or on the web page of the manufacturer of the router, and anybody can access that and then get access to your network. And then also, your router could also have firmware vulnerabilities that has not been patched that could be exploited by the threat actor. And then we also have the DNS spoofing. So your device is communicating with the DNS server and requesting for the address that google.com resides in. Remember, we said DNS server is actually keeping a table, right? And this table assigns, let's say, google.com here. It says Google is at 8.8.8, but now the attacker has actually infiltrated this DNS server, and now it has changed 8.8.8 that is assigned to Google, the original Google address, to um to 3.3.3.3. And then when your device actually requests that, oh, where does google.com reside, instead of DNS server to send 8.8.8 to your device, it doesn't. It sends 3.3.3 because the DNS server has been spoofed. This is what we call DNS spoofing. So now your device thinks 3.3.3 is google.com, and it doesn't go to google.com. It goes directly to the attacker, to the threat actor. And you think you're still browsing google.com, but you're not browsing google.com. You're just giving away your information to the threat actor, unfortunately. So that is DNS spoofing. And then packets in transit as well could be attacked by man-in-the-middle attack, whereby the threat actor actually place themselves in the middle of a communication, and then through that they can do packet sniffing or change data, of giving you the wrong data instead of the right one that has been sent to you, or changing your data that has been sent. So that could happen as well in transit. And then the server too, the Google server could also be infiltrated. There could be server vulnerabilities. There could have been data breaches on this server. They could hack this server, for all I know. So that is why knowing the process of how the internet works is very, very important to us, because all of this process, all of this junction is actually an attack surface for the threat actor. There's something else I actually want to show you guys before we go, which is the hops. Let's bring up our command prompts again, and let me show you something. So we said that for our information, for our data to actually get to its destination, which is Google server, it needs to go through routers, through hops. We can actually find out how many hops it takes our device, it takes our data to actually get to google.com. For me, it could take 20 hops, it could take 12, 13. For you, it could take 2, 3, who knows? But for you to actually find that hop, there is a command we can use, which is trace set. Then we'll do google.com. So what this command is going to do is going to count all of the hops through the routers that this information, this data, this request is going through, for it to show me or tell me how many hops this data needs to get to its destination. So once I press that, it's going to start sending the hop requests, and then it's going to tell me at the end of the day how many hops it takes this for my device to actually get access to google.com. So while this is running, I want you to do this as well and tell me how many hops it took your device to actually, your data to actually get to google.com. My trace has been completed and it took 12 hops, 12 router hops for my data to actually get to google.com. If you remember, we had google.com IP address right here, and you see, we actually have the same IP address right here. So it took 12 hops, 12 hops for me to actually get to google.com. So it took 12 routers. And guess what? I only have one router in my house. They have one router in my house. So it had used 11 other routers. If you remember also, this is my router's IP address, which is my default gateway. So it had used 11 other routers to actually get access to google.com. So please remember to tell me how many hops it took you or took your device to actually access google.com. Now that brings us to the end of this video. And in our next video, we're going to be discussing this OSI framework, OSI model. This is a framework that actually defines exactly how devices communicate at each layer. There are 7 layers, which is the application. Let's start from the lowest, which is the physical, from the first, which is the physical data link, network, transport, session, presentation, and application. And then, so we're going to map each of these layers to real attacks, so you understand exactly where and how hackers strike. We're going to be doing this later in this series, so stay tuned. Subscribe to my channel if you haven't. Like the video if you learned anything at all. Click the notification bell so that you'll be notified whenever I post the next video in this series and other series as well. Thank you and stay curious.